in a AND array format. Okay. So this is the array, and here you can see the data is being written in multiple lists. It's a 2D list. So here you can see this is an array, and these are all the input data that was provided to us over the question. So now we need to separate the features and the classes. So the classes is nothing but the outcome actually, right? So that is the value we have to predict. So that is the outcome. And the data that was provided to us on the var1 and var2 are the inputs. So these are the actual inputs that we need to understand, and these are the independent values that we have, and y is the dependent value. Okay. So now we have divided the data from this NP array. From data, you can see that we have divided the var1 and var2 records and the class data into y. And now what we will be doing, they told that we need to be applying the k value as 3, which is k-means clustering. From the k in the k-means clustering, we need to give the cluster value as 3. And as I told you, the random state is 42. The reason why we put the random state as 42 is after multiple iterations also. 42 is one of the value where we'll be getting optimal amount of data. Instead of having multiple iterations and multiple data sets, 42 is one of the optimal number where we'll be getting optimal data, and we need not to go further. It does not make much difference over there. Okay. So now we apply the same values to k-means clustering, and here we'll try to fit the x data because x is the input. Okay. Now we need to calculate the y value for the new point. So the new point is var1 equals to 0.906 and var2 is 0.606. So we need to predict the y value. This is the outcome, meaning the class. So now we are trying to predict that. So k-means dot predict, we have already provided the x value over the fit here, and here we are trying to provide this value here in the k-means dot predict of, and from here on everything will go into the visualization part. So once you move on, once you train the data with x value and you have the new point being assigned to predict, now you can see that prediction is done, and here you can see the plot. Okay. So in this plot, you can see that we have two classes, which is the blue color one represents 0 as a class. The orange color one represents class 1. Okay. And we have 3 different clusters, and each cluster will have a centroid. So all the 3 centroids were being calculated and being placed as X mark here. Okay. Now you can see that we have a new point. The new point is 0.906, 0.606. So in this scenario, we have kept it here. And once we update this value to predict function from the k-means clustering, what it will do is it will try to predict to which cluster does this belong to. Okay. So we have 3 clusters, and in 3 clusters, each cluster value is like is named after 0, 1, and 2. And after calculating this value, this belongs to 1. So here you can see that the new point cluster assignment is being assigned to 1. Do you want me to manually calculate this and show you? Yes? No? Yes? But I'll only do it for one value. The rest of the values follows. Okay? So good. Thank you. Excuse me. Can someone calculate this value? Did anyone calculate this? This is 0.7, just 0.7. Okay. Anyone calculated the second one? I'm sorry. There is a wrong calculation. 5, 3. This one. Second one 0.77. 79. 79. Is it? This one? This is 79. This is 791. Same values actually. Oh. Four, five, zero, eight, four, four. So out of these three values, hello. So here you can see we have calculated the distance between this new point, which is P, which is this fourth value. And we have calculated the distance between all the three centroids. So out of which you can see that this is the least one, right? So we'll be assigning this to K3, meaning we have three clusters, K1, K2, and K3. And we'll be adding this new point to K3. Okay. So this here you can see we'll be adding P. And this value and this value, you have two values in the same cluster. Now what you need to do, you hit shunt, you need to do the centroid. Calculating the centroid meaning, so you can see that x1 is 2 by 2, comma, y1 plus y2 by 2, which is 0.94 plus 0.353 by 2, 1.566 plus 1.24. Calculated. So this becomes the new centroid. So you will assign this K3 value with this new centroid. So now you did the same thing with this fourth point, right? Now you need to do the same calculation with all the rest of the points as well. Once you are done with calculating all the rest of the points, now we were given the main point as 0.906 and 0.606. So after calculating, it was given that this was assigned to K2. As per our code that we have written, it was predicted that this group will be going to the second centroid. And the second centroid will have multiple values inside the class, and majority of the values has one as its class. So finally, we are going to assign one to this value. So this is how we will be predicting the class using k-means clustering. Is this clear how we did it? Clear? Can I move on from now? Okay. So is the screen visible? Clear enough? Guys, hello. For the ones at the end, clear? Okay. So we have another example where we need to calculate the credit worthiness of that specific person based on the data that was given to us. Okay. So here you can see we have data of the medium skiing design, single, 20s, no. So this is some data, right? So they'll explain it here. So the input attributes are from left to right, which is income, recreation, job, status, age group, homeowner, and this is the risk. Okay. So this is also a classification based program. Okay. So this is, we'll see how this is being handled. So here you can see the income is being medium for the first person, recreation is skiing, and the job is design, status single, age group 20s, homeowner no, and this is provided as high risk. So likewise, we have multiple values. So what we'll do is we'll try to calculate the probabilities. Okay. So first we'll try to read the data that we have from the data that was provided with us. So this is the example data that was given. Now we'll provide this data to calculate the probabilities. And now we'll try to see. So here we need to calculate what is the probability of a person who is having playing golf is single and mid risk. Okay. So in this question, it was given that find the unconditional probability of the golf and conditional probability of single given mid risk in the data set. So now can anyone explain what sort of algorithm that we need to apply in this? So here they are discussing about unconditional probability and conditional probability. Any guesses? Base? Just guess on. Will not directly use Bayes theorem, but here we'll be using the formulas of conditional and unconditional probability. So in the morning that I have explained you, I have given you some equations, right? Those equations belong to conditional probability. And unconditional probability is nothing but the probability of that one specific entity. In the Bayes theorem also, we are having the values of probability of A and probability of B, right? So those are unconditional probabilities. And when the conditional probability is one event occurrence has impact on other event occurrence. So when that comes into the picture and you wanted to calculate the probabilities of that unconditional that scenario, then we'll be using the Bayes theorem. Okay, is this clear till now? Now let's see how we are going to resolve this. So here they told that for conditional probability of single given mid risk, we need to see the single mid risk. So here we have two values, which is A and B, two events, right? So here we have P of A and B, which is A intersection B by mid risk, P of mid risk. Okay. You can say that here we did not have any values that were directly given to us. And how do we do that? How do we calculate this? Because we are not having any numbers over here, but we have data. So we need to calculate the probabilities based on number of instances that value was given. So in this statement, in these statements, you can see that P of mid risk is like number of instances of mid risk is 3 instances. You can see that we have one instance of mid risk, second, third. Only 3 instances of mid risk is there. So the P of mid risk is, so here you can see the number of mid risk. So the P of mid risk will be out of how many values we have mid risk? 1, 2, 3, 4, 5, 6, 7, 8, and 9. Out of 9, we have 3, right? So that becomes the 3 by 9. And number of mid risk instances is 3. Low speedway transport mid 30s, yes. So here we're trying to calculate single and mid risk and also unconditional probability of golf. So you can see that total number of instances and golf instances. So in this golf instance, we can see we'll be getting some values over here. We'll see how many golf instances are there. And here you can see that we have 4 golf instances. Okay. So here we have 4 golf instances and we are trying to print golf instances by total number of instances. So you can see that P goal value is 0.4. I think we have 10 instances. 2, 2, 4, 6, 7, 8, 9, 10. Yeah, we have 10 records here. Okay. So we have 10 records. Out of 10, we have the golf value repeating 4 times. Guys, please pay attention. So now we can see that the probability of golf is 4 by 10, which is 0.4, which is 40%. So this is unconditional probability. Now, when it comes to the conditional probability, this is where we'll be applying the Bayes theorem. Okay. In this Bayes theorem, you can see that, so number of mid-risk instances we can see we have number of mid-risk instances and we'll see how many number of mid-risk instances are there. Total mid-risk instances are 3. Okay. Now we need to see when the mid-risk and also single comes into the picture. In the given data, we have single people who are also at mid-risk. So in that scenario, first we need to identify in which scenario we have both single and as well as mid-risk is also there. So now you can see So single and mid-risk instances are two. Okay. So now we need to identify what is the probability of person who is single and also mid-risk. So in that scenario, what we will be doing? Single mid-risk by total number of mid-risk. If the total mid-risk is greater than 0, then we will be printing the data. So we have two scenarios where we have both single and mid-risk, right? Which is A intersection B, and the mid-risk value, which is unconditional probability of the mid-risk value is 3, right? So 2 by 3, which is equals to 0.67, which is 67%. So this is what we are asked to calculate. So here you can see we have applied Bayes theorem. We have also applied unconditional probability. Okay. Is this clear, or you want me to explain it over the board? Guys, you want me to explain over the board or board? Okay. Okay. Have a look at the data once. Okay. ఈ రెండు పక్క పక్కన పెట్టడానికి అవుతుందా ఇది అది ఇది రాయడానికి రెండు పక్క పక్క కావాలి నాకు. మినిమస్ మినిమస్ చేద్దాం. నాకు క్వశ్చన్ కావాలి. ఇది ఫుల్ స్క్రీన్ ఆఫ్ చేయండి. ఫుల్ స్క్రీన్ ఆఫ్ చేస్తారా? ఇందాక సగం వచ్చింది కదా. దాని మీద రాయొచ్చు సార్. జూమ్ మీటింగ్ రాసుకోవచ్చా? అయితే అదే ఓపెన్ చేయండి. ఇందా నుండి దీని మీద ఎందుకు కష్టపడుతున్నాం మనం? యాక్చువల్లీ మీరు స్క్రీన్ షేర్ చేయకూడదు, నేను అక్కడ ఆల్రెడీ స్క్రీన్ షేర్ చేశాను కాబట్టి అక్కడ కనిపిస్తుంది.
అది కనపడదు, లైవ్ లో రావట్లేదు.
లైవ్ లో రావట్లేదు,
ఇక్కడ రాసేది రావట్లేదు.
మరి ఏం చేయమన్నారు? So, guys, hello. Can you hear me? Yep. So, just have a look at the data. So we were asked what is the unconditional probability of having golf, playing golf, right? A person given playing golf. So we have 10 members data over here. We have golf in here first, second, third, and fourth, right? Out of 10 persons values, we have 4 persons who are playing golf. They asked about the unconditional probability of one given person playing golf. So that is the first question. So out of 10 records, we have 4 records, which is stating the person is playing golf. So that is the probability of person playing golf is equals to 4 out of 10, which is 0.4, which is 40%. So this is the first question's answer. This is clear. So the second question is, they are asking about if the person is single at the same time, a person is also at the mid risk. So now we are going to apply the Bayes theorem. Okay. In this scenario, first we'll see how many mid risk were there to identify what is the P of B value. Okay. So now we'll see how many mid risk values are there, out of which we have 1, 2, 3. So there are 3 mid risk values, which is P of mid risk equals to 3. Okay. And we will also see where we have mid risk and also the person is single. Okay. So here you can see this is mid risk and the person is married in the first scenario. In the second 2 scenarios, you can see that mid risk, and the person is single. So out of these many places, we have only 2 scenarios where you have mid risk and as well as the person is single, right? So now what happens is, this is, let's say mid risk is B and the single is A. P of A intersection B is 2. Okay. So we have mid risk is B, right? So now we need to calculate P of A occurrence when B occurred, which is A is being single at the same time mid risk, meaning P of A intersection B by P of B, which equals to A intersection B is 2 by the mid risk is 3, which is close to 67%, approximately equals to 67%. So now you understand how we have calculated this we have calculated the probability using the Bayes theorem, conditional probability and unconditional probability. Clear? Any doubts? Doubts? Clear? So we kind of did the same thing over the code as well. So here we have added the data that we have into the past data. And here we are kind of trying to calculate the probability of golf. So here you can see that the total number of instances where we have golf as the recreation, and these golf instances, we are trying to identify calculating the probability of golf. So total golf instances by total instances, which is 4 by 10, we are getting 40%. And here calculating P of single by mid risk, we have 2 instances of single and 3 instances of mid risk. 2 instances where single and mid risk are also there. Okay. So now we'll be getting 2 by 3 as 67%. Now we'll see what is it. So we have the P goal value as 40% and P of single by mid risk is 0.67% approximately. Okay. Now is this clear how we have calculated? Okay. I hope this made some sense. We'll try to move on to the next question. So the next question is the implementation of linear regression. First, I'll try to help you what is meant by linear regression, what are its use cases, and what are multiple scenarios in it. And then we'll discuss about how the implementation of linear regression is there. Okay? Yeah. Okay. So in the morning session, we have discussed about KNN regressor. So what did we calculate using KNN regressor? Sorry? Yeah. So when we have some quantified data and we wanted to predict that quantified data with the data that was given to us, then we will be using the regressions. So there are multiple types of regressions that were there. So KNN regression is one of the kind that I have explained you in the morning. There is also another regression which is called as linear regression. So even in linear regression as well, in your mathematics, we generally use a formula called as y equals to mx plus c, right? So we will be kind of using such similar scenario in our linear regression. Once you have x and y values, and these values are plotted on a line, okay, then we'll be using the linear regression to identify predict the next values. So in a normal linear regression, simple linear regression, we have only one x value and one y value. These x values will increase a lot eventually. So first I'll explain you how we are calculating the simple linear regression, and then we'll move on to the multilinear regression. So multilinear regression meaning we'll be having multiple x values, meaning multiple independent values, where those will be helpful for us to identify the dependent value, which is y. Okay. First, we'll try to put these values in a graph. So now you can see we have multiple values here. So these values are not directly, so we cannot uh, draw a direct line meeting all the points that we have here, right? So 1.2, 1.8, 2.6, these have multiple differences. So here 1.2 and 1.6 has 6, and 1.8 to 2.6 has difference of 8, and here to here we have again 6, and here to here we have 6. So this is one value which we cannot directly draw a line through. So if you draw a line through this, so this value will be, we cannot touch that value, right? So this is called as slope intercept form, right? This is the intercept, this is the slope, and you have to calculate this value, which is y equals to mx plus c. And if here we have a point where we'll not touch that through the intercept that we have drawn, sorry, the slope that we have drawn, right? So here we'll be having a error. So there is a mean square difference. You have, when you draw a perpendicular line to the slope that we have drawn, we'll be having a difference between the point and the line. So that is the error. Okay. So if you want, we can in general, so this is the slope intercept form, but when it comes to the statistics and probability, we'll not use this nomenclature. We'll be using a naught plus a1x plus e, which is error component. So for now, we'll forget about the error component. And now what we'll do is we have a formula for this a1, which is x and y whole mean minus x mean into y mean by x square whole mean minus x mean whole square. This is a1 value. And if you come to a naught, y mean minus a1 into x mean. So this is nothing but this statement came from the same statement that we have over here. So once we try to calculate the A1 value, we'll be getting all the values of A1. And now if a new point is given to you, let's say you have 6 and you have to calculate this value, you'll have A0, A1 to find Y, right? So that's how we are going to predict. And also consider that we have a error here. So with the points that were given here, so we need to find the mean value, which is mean of X, which is X bar, and mean of Y, which is Y bar, and also X and Y whole mean and X square. So all these value will try to substitute all these values. I have already calculated them. 8.88, which is XY bar, minus 3, which is X mean, 2.5, 2.52, which is Y mean, by X square mean, which is 11, minus X mean whole square, which is 9. So this value becomes 0.66. So 0.66 is your A1 value. Okay. Now in order to calculate this value, we have a y mean value here, right? Which is 2.52. A naught equals to y mean. Y mean is nothing but 2.52. 2.52 minus this value, which is A1 into X mean. The A1 value here we got is 0.66. So 0.66 into Y mean is 3. So this value becomes 0.54. So the total equation would be, now what happens out of these values, we'll have the equation y equals to 0.54, which is A naught, plus 0.66 into x. Now, let's say we wanted to calculate some value of what is the value we'll be getting out of 6. So this 6 is independent value, which is x. We'll be substituting that over here, which is 0.54 plus 0.66 into 6. So this is, I did not calculate, which is 4.5. So if we have a sixth point over here, it will be meeting at somewhere at 4.5. Okay. So this is how we are going to predict when we have a linear regression of simple values, which is x and y. We only have one independent value and one dependent value. So this is called a simple linear regression. And we also have something called as multilinear regression. So in multilinear regression, what we'll be having is, we'll be having multiple values, multiple x values, which is independent values. Here you only have x. There we'll be having x1, x2, x3, x4, and so on. So in such scenarios, what we'll be doing, we'll see now. So that's when we'll be using the concept of matrices. So in this scenario, we only have two x1. Guys, hello, just have a look at it. So now we have x1 and x2, where these x1 and x2 are independent values. So the equation goes as like this, which is y equals to a naught plus a1 x1 plus a2 x2, and so on becomes an xn. Okay. So when you have these many values, earlier I have given few formulas. Those formulas will not work as straightforward as this, because you have to deal with multiple values here. So in this scenario, we will be considering the calculation using matrices. So we'll convert this entire data into matrix format, which is we'll have x, which is equals to we'll have we have four values here. Right. So initial value is 1, 1, 2, 3, 4, 4, 5, 8, 2. And these are the y values. So we'll put all the y values here, which is 1, 6, 8, and 12. Okay. So here what we'll be doing is, in order to calculate A, so here earlier we have tried to calculate the mx plus c format where m is the slope. So now we are having multiple values of A's, multiple slopes here. So in this scenario, what we'll be doing is, we need to have A, which is A naught, A1, A2, right? So here we have only x1 and x2. So that becomes, in this scenario, y equals to a naught plus a1 x1 plus a2 x2. So here we are only having 3a's, right? So that is the reason we'll be having here 3a's, a naught, a1 and a2. So now we'll apply, in order to identify this, we'll apply a formula called as a equals to x transpose into x whole inverse into x transpose. And this is being multiplied with y. Okay. So first we'll kind of I'll not do the entire calculation here. So I'll just help you out how I'll tell you how we are doing this. So first what we'll do is try to do x transpose into x. So that will give you so this, you can see this is 3 by 4 and this is 4 by 3. This will lead to 3 by 3 matrix. So this value becomes, and also after getting this, you need to do inverse. So once you perform inverse also, you will be getting 3 by 3 matrix. Okay. Once you get 3 by 3 matrix, and again you multiply that with x transpose, again you will be getting 3 by 3 matrix only. And then you will be multiplying that with this one value. Then you will be getting this A value, which is 1 by 3. This is x transpose, and then multiplied. This will return 3 by 1. And once you multiply all this, you will be getting 1 by 3 matrix. So at the end, you will be getting only 3 values. After calculating those values, you can directly assign to these values you have in this A matrix. Okay. When you are having multiple values in the A, or multiple x values, this is how you are going to calculate the a values. And in this scenario, if now some value is given, which is 5, some 7, and you need to calculate this after identifying the values here, you can directly upload these, assign these values over here, substitute, and you will be getting the y value. So that's how you are going to predict multilinear regression. So there are few drawbacks in this multilinear regression and linear regression. Okay. So the major drawbacks of multilinear regression and linear regression here is all the points has to be very near to each other. So I'll just draw you two graphs. Just explain me which is good with linear regression and which is not. So in these two graphs, in which case the linear regression would help you to predict, guys? Hello. So in these two cases, which case will help you to predict the better values? In these two cases, this is, let's say this is A graph and this is graph B. A. Why? You have most of the points close by to your slope intercept, right? And these values are very near, meaning here this is called as linear graph. But when it comes to here, in this scenario, this is not a linear graph. Here all the values are being scattered. Okay. So in this scenario, we will not be able to apply linear regression. So based on the data that we have, putting it on the graph will help you to understand which linear regression will you be able to apply linear regression to that specific data or not. Okay. Linear regression, let's say you might have the data, you might have written the code in such a way that you have R squared value very near to 1 or also 1. Even in that scenario also, your linear regression will not work just because of the data that you have taken. It can be real data, it can be a correct data that you have taken, but your specific algorithm will not help you to predict the data correctly. Then your accuracy will be low. Okay. Is this point clear? Everyone? Okay. And we also have a concept of gradient descent. I'll share that in the code. It's kind of a bit complex where you will have differentiations included in it. So if you want me to explain, I'll explain it, but it is not much needed. But I'll explain you that in a simple terms. So here we have predicted, we have calculated y equals to mx plus c. We have a trial and error method to do that as well. We have, so earlier I told you that we have some points where these points are not there on this line, right? So what we'll be doing, we'll be calculating mean squared error, correct? So that is called as error component. I already told you we have y equals to a naught plus a1x plus error, which is error component. So this error is nothing but the mean squared error component. Okay. So in this scenario, when you have multiple mean squared errors, you can directly give it. But after drawing a line also, we can also find the best fit for this. So that's when the gradient descent comes into the picture. So the gradient descent will help you to identify the best fit to which you'll have the data and try to fit all the data in the line with less mean squared error. So even in the morning also, I have told you that after a point, some values will the error will increase, right? So after calculating, there is some formulas for identifying the error. And in that scenario, we'll be calculating errors by changing the A0 and A1 values. Okay. So for that, let's say you have A0 and A1 values. A0 and A1 values. Let's say you have started at 0, and after putting them, sorry, this is error. This is A values and this is errors. So once you try to change the slope value, which is M, what happens is this will eventually start increasing or decreasing. If it is increasing, you have to decrease the value from which you have started. If it is if it is decreasing, you have to eventually change the A0 values by increasing it. So it will eventually stop, go to a steep down. So we should not directly jump from this point to this point by directly changing the values. By doing multiple iterations, by doing multiple calculations, I'll show you the what sort of calculation that we'll be doing. So after doing that, what happens is you have to reduce those values eventually and do multiple iterations. So earlier also I told that there are multiple iterations, and for every iteration value I have given it as 42. So this is the point that I was referring to. Okay. So here this will stop. After a point, let's say this is a point, it has reached the minimum mean squared error, which is also called as a cost function. This will start increasing. So the point at which it will start increasing, you have to consider that as this is the least mean squared error, and consider this with the A0 and A1 values. So with those A0 and A1 values and the data that you plot, that will help you to predict the data that you wanted to predict accurately, more accurately. Okay. Is this clear till now? Now we'll see how the simple linear regression is working. Okay. Here also, I am kind of doing the same thing that we have done in the KNN regression and KNN classifier. Guys, hello. So here also, I am kind of doing the same thing that I have done with KNN classifier and KNN regressor. So I'll try to have some data. I'll try to divide the data into training data and testing data and see whether my logic that I have written is helping me to predict the values better. Okay. So here you can see that I have a class called a simple linear regression, and this fit value will take two values, which is x and y, and convert that into the inputs, and will calculate the mean of x and y. Now we have to calculate the slope value with the same formula that I have told you. I'm calculating the slope value, which is the sum of mean x minus x mean into y minus y mean. and denominator is x minus x mean whole square. So now we'll calculate the intercept, which is here you got the slope, which is numerator by denominator will help you to calculate the slope, which is a1x, a1. And now we are trying to find the intercept value, which is y mean minus x self dot, slope into x mean. So you want me to, okay, it's here, right? Oh, I'm sorry. You're not looking at. Yeah. So even in the code also, I'm doing the same thing. So this is the numerator and this is the denominator that I'll be calculating in the code. I'll share the screen. I'll explain you that as well. So we'll be getting a naught first, finding the a1 values, and then we'll calculate the a naught and find the equation y equals to mx plus c equation and see how it is getting predicted. So here I have a class which is simple linear regression and it has a slope and intercept format. Okay. And I have a method called as fit, which is taking two parameters, which is x and y. And I am converting that into x and y input numpy arrays. And here you can see that I'm kind of finding the mean of x and mean of y. So once you find the mean of x and mean of y, we can calculate the numerator, which is sum of x minus x mean into y minus y mean. The denominator is again sum of x minus x mean whole square. So now with the numerator by denominator, we'll be getting the slope value, which is mx plus c, which is m. Okay. Once you find the m value, you can calculate what is the constant value, which is the intercept. So the intercept value is y mean minus the slope into x value, x mean. So x mean is nothing but the data that we have. So I have taken 5 values, right? So out of all the 5 values, we'll be taking the mean of x and the mean of y. Mean is nothing but the average. Okay. Now we'll try to predict the data. So here it will take the x values, which is the trained value, and then we'll try to return the slope into the intercept. Slope into x into intercept. And this goes into the plotting of data, and this is r squared value. So for our example, I have taken 1, 2, 3, 4, 5, 5 values, which is x, and the y values is 2.1, 3.8, 5.2, 6.9, and 8.3. So these are dependent values and these are independent variables. So now I kind of pass that to the fit function, which is x comma y, and you can see that data is being fit into the algorithm that I have written. Okay. After that, so this is the simple linear regression plot that we have, that I have plotted with the data that it was given. So after calculating, is anyone there? Ah. Guys, hello. Just hear me out. This is the last question that I'll be dealing with. Later on, I'll just give you a recap of what we have done till now from the morning. Okay. Yeah. So this is the slope intercept form. After calculating the slope intercept form, this is the equation that we got, which is y equals to 1.55x plus 0.61. So a naught value is 0.61 and the m value or a1 value is 1.55. So after plotting these values with the given data, this is the graph that we got. And here also you can see that few of the points are not directly aligning on the line. Guys, here also you can see that most of the data points that we have are not completely aligning with the line that we have drawn, right? So after our predicting after our prediction. So these are the values that we'll be getting for 6, 7, and 8. Okay. So after predicting these values, we'll be plotting that on the graph, and you can see that these values are directly on the line. Now, did you understand why these points are directly on the line with no deviations? Because we just substituted the values of x and y, which is directly pointing on the line. 0, 1, 2, 3, 4, 5 till 5. These are the given values, and last 3 points are completely predicted by the line. Okay, by the equation of the line. So that was the reason these are perfectly aligning with the line that we have drawn. So now you understand how the linear regression is working. Any questions till now? Any doubts? So at the end of the day, I'll share all these collab files with you guys. Just go through that. I'll also try to put that gradient descent data. Just go through that. It is a bit calculative, so that it will take a lot of time. The only intent of that gradient descent is like to make you understand how that is working, so that I have explained you. Just try to go through the calculations. But the major reason why we will be using the gradient descent is to calculate the most best fit line on the linear regression. So is the concept of linear regression, KNN, K-means cluster, Bayes theorem, everything clear? Okay, let's take a 5 minutes break. From then on, I'll explain what we have. Take a quick recap.